Hello and welcome. This is Science Visualized. Today we're presenting dipoles and dipole moments. So dipole moment is also written as mu. Dipole is used to show if the bond is a polar covalent bond. That means one side of the bond is partial positive, the other side is partial negative, and you use an arrow like this. So the head faces to the partial negative, and then the tail you cross it to look like a plus sign, and that one faces the partial positive side. The dipole moment, on the other hand, is used to determine whether the full molecule is polar or not. So if the net dipole moment is not 0, then we say the molecule is polar. But if mu equals to 0, then we say it's non-polar. Electronegativity. This is the ability of an atom to pull bonding electrons towards itself. So for example, if you have two hydrogen atoms, the electrons will be symmetrically located between the two hydrogens because they are equal in electronegativity. But if you have something like, say, hydrogen and oxygen bond, the oxygen is going to be more electronegative, so we use a delta negative, and the hydrogen will be less electronegative, so we use a delta plus for that. And that's because oxygen is more on the right in the periodic table. So we see that the electronegativity increases from left to right, and also it increases from bottom to top. And from there you can see that hydrogen is in group 1, while oxygen is in group 6. So you see that oxygen is more electronegative. Now let's apply this. Looking at this molecule, we have hydrogen and chlorine, HCl, hydrogen chloride bond. And the first thing for us to determine is whether this is a polar bond. Chlorine is in group 7A, therefore it will be partial negative, while hydrogen is in group 1A, and therefore it will be partial plus. So we see that this bond is polarized, so it becomes a polar covalent bond. And we can either use delta plus and delta minus to show that, or we could use the dipole arrow where the head faces the partial negative and the tail faces the partial plus. And because this is the only bond in the molecule, so the mu is not 0 because we see that the bond is polarized. So it has a net dipole moment, and therefore it is a polar molecule. Next, we see water, and we know that oxygen is in group 6A, while hydrogen is in group 1A, and therefore oxygen is going to be partial negative, hydrogen will be partial plus, or we can use a dipole arrow where the head faces to the partial negative, the tail faces to the partial plus, and then the same thing on this other side. But water also has two lone pair of electrons. Each of those counts like one thing. And you have to show the sp3 hybridization, sp3, where one bond is coming out, the other one is going in, and then the other two bonds are on the plane. So in this case, we need to show the dipole for the lone pair of electrons, and because electrons are highly electronegative, we're going to have very big dipoles, like that, facing to the negative, and like that. So the dipole moment, mu, equals to, you start adding all the dipoles in the molecule. So when you add these two and that one, you end up with something that looks like that, goes up, and then when you add these two and that one, you end up with that. So basically you have that plus that, and all of it pulls in that direction, so you end up with a net dipole moment facing that direction. So we say mu is not equal to 0, and therefore water is a polar molecule. Thank you very much for your time. Please support the channel by subscribing.